Welcome to Science Access. Today I'll be diving on the integral series. Please, if this is your first time of visiting this channel, please kindly like and press the notification button just to get notified when next we post new video. We now dealing with the series of integration. Please, I want you to, for better understanding of this one, because integration is the most complex part of calculus. You need knowledge in limits, you need knowledge in differentiations before getting acquainted with this one. So please, I'll urge you to visit our previous video on our limits series and our differentiation series for better understanding. So now we will start with the introductory part of integration. We start with the introductory part of integration, and then I beg you to settle yourself before we start. Now, integration, we all know that integration is the reverse of differentiation. The reverse of differentiation. Maybe you differentiate something. The reverse of it is integration. So now, as stated on the board, integration is the reverse process of differentiation. Integration, I reiterate, integration is the reverse form of integration. Let's say, for example, now we have a variable like this. Let's say y equals x raised to the third power, right? Now, the differentiation is the y, differentiation of y respect to x, the y dx equals 3x squared. Now, what did I mean by this? This x raised to the third power is the integral form of this one. Right? Yes, that's it. That's the reverse of differentiation. Going back again is what we call meant by differentiation and integration. So the reverse of differentiation is integration. I want you to know that before we continue. And now the integral x raised to the power of n. Now we start with standard integration, standard integral. Now, for example, this is the introduction part of integration, because integration is very broad. As I told you before, for better understanding, pay reference to our previous video. Integration, if f of x equals x raised to the power of n. I told you we'll use the same rule here, right? Now, you know that when you see large x, you just go for integration. Whatever I say that, to know that you are dealing with integration. Now, integration sign, this is the integration sign. Remember, x, which is the variable, and n the power, right? dx equals, now, you know, remember our differentiation, right? When you see something like this, and remove one from the power, right? Now, no, the reverse of this one is integration. Instead of removing one from the power, we add one to the power instead. That I told you, the integration is the reverse form of differentiation. We add one instead of subtracting one. So, integral x and dx equals, now, you see, x n plus 1 all over the power n plus 1 plus c. Plus c. If you miss the constant, where c is our constant, you must always add the constant. Excluding the c, without the c now, this answer is not correct. Excluding the c from this place now, the answer is not complete and not correct. When dealing with integral, you must pay reference to the constant. C must be there, which is the constant. Unlike limit and differentiation. Please, I want you to know that. I told you before, integration is the reverse of differentiation. Differentiation, we subtract 1 from the power. When integration, we add 1 to the power all over the power itself. You see, we added 1 to the power, which is n plus 1, all over the power plus c. This is for you should have this in mind so that when solving other questions, you will know what we are all talking about. Now, let's just say, let me solve our first example. Now, integral x raised to the power of 8 dx. Integral x raised to the 8th power dx. Now, equals, remember what I told you, right? X raised to the 8th power plus 1, right? All over the power 8 plus 1 equals x 8 plus 1, 9, right? All over 8 plus 1, 9 plus c. This is the answer for this one. We are just dealing with standard integral, right? For now, we have partial integral and so on. So this is the basics. This is the knowledge you have to have for the now before we dive in other methods, other integral parts or perspectives. And now going to other questions. Question number 2. Now we are solving for the integral of sum and differences. We are solving for integral of sum and differences. Example. Now find the integral, bracket open, 2x raised to the 4th power plus 3x raised to the 2nd power dx. You see? Okay, now s equal to integral. Now we see we have two functions now. You see, remember the first one, we were just dealing with 8x, right? This time around, it is 2x raised to the 4th power plus 3x raised to the 2nd power. So solving this question, we find the integral form of the two functions. Okay, now pay reference to this one first. Equals integral 2x raised to the 4th power dx plus integral 3x raised to the 3rd power dx. Okay, yeah, we are getting it. Yeah, very true. Now equals, now I want you to pause the video to try and solve this one. Remember the step I told you before? For you to know what we are dealing with, I want you to pause the video and try it yourself. Yeah, I want you to do that. Okay, now solving this one now. 2x, 4. I told you before, remember, if it were differentiation, we remove 1 from the power, right? Yes, we remove 1 from the power. Now, since it is integration, I told you integration is the reverse of differentiation. We add 1 to the power, right? Equals the power 4 plus 1 plus the integral form of this one, 3x raised to the 3rd power plus 1 all over the power, right? Power plus our constant c equals 2x 4 plus 1, 5, right? Raised to the 5th power now, all over 5, right? Yes, plus 3x 3 plus 1, 4, right? All over 4 plus c. This is the answer for this one. So this is just the starting points of integration. I want you to know this one. I want you to know what we are saying. That is it. Now, moving to the third example. Integral 3 all over x dx. As you can see, this one is quite different from the rest. This is fraction form, right? Yes, fraction form. How do we go about this one? How do we go about this one? Okay, now let's try this method if it works. Okay, now since we're dealing with fraction, right? So we factor this one there. We'll bring this 3 out, right? This 3, bring it out. 3 integral 1 all over x dx. We simplify this one to this one. So to get the accurate and precise answer. We cannot just divide how maybe some of you are just thinking we cannot add one. We cannot do anything except this one. This is the best approach to this one. We factor these three out. Back of the integral, right? The integral sign. 1 all over x dx. Now multiplying this up with this one will give you this one, give rise to this one. So now from here now it is easy now. It is easy, very, very easy. Now equals 3. Integrate 1 all over x. Integrate 1 over x. Remember that when we differentiate, remember our differentiation, right? When we differentiate log ex, right? We have 1 all over x. Remember that, right? Now, remember integration is the reverse of differentiation. Now, since we have this one as the question, this will not be the answer to this question here. Now, integral 1 all over x dx is 3 log ex plus c. This is the answer. As I told you, for you to get a better understanding, pay reference to our previous video on differentiation and limits. 3 log x plus c or 3 natural log x plus c. This is the answer for this question.